Okay, this is a review of working with quadratic equations in vertex form. You'll find that what we learned right at the end of last trimester is going to be important as we look at 5 and move forward. But here I have an equation, a quadratic. It's in vertex form. F of x is equal to x minus 3 squared minus 4. Now to recall, the vertex of this quadratic will be at x is equal to 3 and y is equal to negative 4. We move 3 units to the right and 4 units down. So if I graph the vertex, that would be x is 3 and y is negative 4, so there we go. So that would be my vertex here, 3 minus 4. Okay, but we also learned how to calculate the zeros of a quadratic, both by factoring and in standard form. To find the zeros of a quadratic, you set the function equal to 0 and then you solve for x. So here I have, so f of x will equal 0, or y will equal 0, and then we have x minus 3 squared minus 4. To solve that, we'll solve for x, so first we'll add 4 to both sides, and we'll get 4 is equal to x minus 3 squared. And then we'll take the square root of both sides, keeping in mind that when we take the square root of both sides, we always have a plus minus. Okay, so that will give me then plus minus 2 equal x minus 3. And then lastly, we'll add 3 to both sides, and we'll get plus or minus 2 plus 3 plus or minus 2. Let me clear that up just a bit. Equals x. So x will equal 5, 2 plus 3 is 5, or x will equal 1, negative 2 plus 3 will equal 1. So my zeros will be 1 and 5, and I can graph those as well. So 1 0 was x is equal to 1, and the other 0 is x is equal to 5. Okay, so when we found the zeros of a quadratic at the end of last try, we were actually trying to find out where that parabola crossed the x-axis, or what were the zeros. And if I wanted to find out the y-intercept, I would just evaluate the function at x is equal to 0, and that will give me 0 minus 3 squared minus 4. And then so that would be 9. Negative 3 squared is 9, and 9 minus 4 would be 5. So that will equal 5. So my y-intercept would be at 5. And then I can graph the quadratic. Okay, so it will look like that. So notice again that I found the zeros. That's where the quadratic parabola crosses the x-axis. Okay, so that's what we did last try. Let's just take a look at another one. Let's say here if I had this quadratic here. And clear off the board. Clear that off as well. So let's say here I started with this here. I had, so let's say here f of x is equal to negative x squared plus 8. My vertex here, well, that I didn't move anywhere left or right, so x will remain 0. But I shifted my graph up by 8. Okay. The leading coefficient is negative, so this will be a sad graph. It will be pointing downwards. So let me graph the point 0, 8, and that will be somewhere about up there. 0, 8. So that would be my vertex. X is 0. Y is 8. So let's go ahead and find the zeros. Okay, so we have to set f of x is equal to 0. We're going to find where that quadratic parabola crosses the x-axis. So 0 equals negative x squared plus 8. Subtract 8 from both sides, you get negative 8 equals negative x squared. Multiply both sides by negative 1, and I get 8 is equal to x squared. Square root both sides, and then I get plus or minus root 8 equals x. Okay, we should always simplify the radicals, so root 8 is equal to root 4 times root 2, and so this will be plus or minus 2 root 2 equals x. Okay, so those will be my zeros. Now 2 root 2 is approximately 2.8 something. So I'll have two zeros, one at negative 2.8 approximately, and the other one at 2.8. So if I were to graph those zeros here, and that would be at about 2.8, so somewhere about right here, and then negative 2.8, and that would be about right there. And my graph would be a sad graph, so it's a parabola that faces down. Okay, but notice in each case, the first case, the first quadratic we looked at, and this quadratic, notice that in each case the parabola crossed the x-axis. Or in other words, we had zeros, real zeros. Okay, in the prior example, our zeros were 1 and 5, if you recall. In this example, our zeros are plus or minus 2 root 2. Okay, but we had zeros that were in a real number system. Now, if you recall, the real number system is made up of both rational and irrational. The real number system is made up of both rational and irrational. 1, 5, the zeros we had for the first equation, that would fall in the rational system, under the rational category, and then the other 2 root 2 that would fall in the plus or minus 2 root 2 that would fall in the irrational. But in either case, we had solutions, zeros, that were in the real number system, rational or irrational. Now, what we're going to be working with this in 5.5, we'll have solutions, though, that aren't in the real number system. They'll be in a complex number system. Okay, and just as we move ahead, I guess we'll see that when we have those type of solutions that are in a complex number system, we'll generally have a negative under the square root symbol. So let's take a look at an example here. Okay, so let's take a look at maybe this example here. So let's say here I have a parabola. Okay, the equation is x squared plus 5. Now, again, the vertex, I did not move anywhere left or right, so x is going to be 0, but y will be 5. Okay, it's a happy graph, so it will be pointing upwards. Here's my vertex, is at 0, 5. Okay, if I evaluated that at f is 2, f of 2, that will be 2 squared plus 5, and that will be 9, so the 2 and 9. And then if I evaluated that at negative 2, that 2 would be at 9. So negative 2, 9. And so if I were to graph that, let's see here, at 2, 9, that would be somewhere up here. And negative 2, 9, that would be somewhere up here. But notice here that that parabola will never cross the x-axis. It just doesn't cross. So we'll say, in that sense, it doesn't. This quadratic will have no real solutions. In other words, it will not cross the x-axis. So let's just go ahead and see what we get when we try and find the zeros of that quadratic. Okay, so this is what we have. So again, we'll set f of x is equal to 0. 0 equals x squared plus 5. And we'll subtract 5 from both sides. We'll get minus 5 equals x squared. And then now we'll take the square root of both sides. Okay? But notice here we have a negative underneath the radical. So our solution here will be plus or minus negative root 5. Well, okay, we need a way, however, because algebra is all about trying to solve for unknown variables using math, we need a way to be able to deal with this negative underneath the radical. And the way we'll deal with that is mathematicians came up with this solution. They said this: we'll have negative 1 be represented by something we call I. Okay? I, an imaginary number. All right? Okay, and so my solution here then, I'll say is, I can write it this way, plus or minus, so negative 1 times square root of negative 1 times the square root of 5. Or plus or minus I times root 5. Okay. So when we get a 0 that has in it I or a negative 1 or negative underneath the radical, we'll have what's considered an imaginary solution. Okay. In other words, the parabola is never going to cross the x-axis. So it's going to be very easy to see when we have imaginary roots, because the parabola will never cross the x-axis. Okay. So what I'm dealing with then is what's called the complex number system. Complex number system. In this complex number system, though, is going to consist of two things. It's going to consist of the real numbers, the rational and irrational. But then we're going to add to that the imaginary number system. Imaginary number systems, and that will include things like I, or what we saw in this case, I root 5, or 2I, yada yada yada. Okay, so we'll be including in this. So this will be the complex number system, and that complex number system will both have real solutions or imaginary solutions. Imaginary numbers are real numbers. Okay, so the complex number is about as far as we can go in terms of hierarchy. Okay, all along we've just looked at solutions that were in the real number system. Now we'll have to take into account solutions that will also have imaginary numbers. Okay, or in other words, we'll have a negative underneath the radical. Okay, and it's always easy to be able to identify that because the quadratic parabola will never cross the x-axis. Okay, maybe if okay, so for example, let's say here, if I had this, if I drew, maybe another good example is if I had this, if I had f of x equals negative x squared minus 4. My vertex would be at 0, minus 4. So my vertex would be down here, so 0, minus 4. It's a sad graph. It's a sad graph, so it would point down this way. But notice again, it will never, that parabola will not cross the x-axis. It's going to have imaginary roots or imaginary zeros. And we can see that if I solve this one here, if I tried to find the zeros for that function here, well, let's do this here. So I'll set f of x is equal to 0, 0 equals negative x squared minus 4, add 4 to both sides. 4 equals negative x squared, and multiply both sides by negative, and I'll get negative 4 equals x squared. Take the square root of both sides, and then what I'll get is plus or minus root negative 4, which is going to be plus or minus root negative 1 times root 4, which would be plus or minus, well, root 4 is 2, so, and root negative 1 is I, so this would be plus or minus 2I. Okay, so my final solution would be x is equal to plus or minus 2I. Again, I had an imaginary, I had part of my solution, or root or 0, included an imaginary number. You see, because the parabola never crossed the x-axis. All right? All right, and so that's an easy way to identify whether or not you'll have imaginary answers. If the parabola does not cross the x-axis or even touch it, you will have imaginary answers. You'll have a negative in the radical. All right, and so that's where we're going with this, okay? So we're moving to a higher level of mathematics. We're dealing with the complex number system, which includes both the real solutions and imaginary solutions as well. Okay, so before we do that, though, we just have to keep in mind a couple of things. We'll define that the square root of negative 1 is equal to I, and if I take the square root of negative 1 times the square root of negative 1, or that will just equal I squared, we'll say that equals negative 1. And so the two things that we'll have to remember when we work with imaginary numbers is that the square root of minus 1 is equal to I, and I squared equals negative 1. Okay, very, very important. So those are, the two takeaways here. We have to keep that in mind. The square root of negative 1 is I, and I squared is equal to negative 1. Okay, so just some practice. If I said here, the square root of negative 4, will that equal the square root of negative 1 times the square root of 4, and that will equal, so we'll say I, 2, but then we always write this here just 2I. Okay, so the square root of negative 4 is equal to 2I. All right, if I had like 3 times the square root of negative 16, again, that would be 3 times the square root of minus 1 times the square root of 16, which is 3 times I times 4, which is equal to 12I. Okay, 12I. Let's see here. Okay, just some more practice. If I said x squared, if I solved x squared is equal to negative 49, take the square root of both sides. Okay, we get x is equal to plus or minus the square root of negative 49, which is plus or minus square root of negative 1 times the square root of 49, which is plus or minus I. And the square root of 49 is 7, but we would write that plus or minus 7I. All right. And then lastly, never make this mistake here. Never ever do this. And if I said this here, if I said, hey, what is the square root of negative 4 times the square root of negative 4? Do not be tempted to say that is the square root of 16. Okay, thinking that you can take negative times a negative and get a positive. That is absolutely wrong. What you would do is you would write this the square root of negative 1 times the square root of 4. And then this would be the square root of negative 1 times the square root of 4. And this would be I times 2 times I times 2. And then 2 times 2 is 4. And so, and I times I is I squared. But recall I squared is equal to negative 1. So this would equal negative 4. Okay, so the square root of negative 4 times the square root of negative 4 will equal negative 4. And that's really not much different than if I said, hey, what's the square root of 3 times the square root of 3? You would just say, hey, that's 3. Because this goes, okay, so it's really not much different, but never ever make the mistake of multiplying these here together. Okay, and getting a positive. All right, and so that's it in a nutshell, and so we'll work through some problems here in class.